Hello. So today we are going to start with probability, and before even starting with probability, we will discuss what is probability and what are the basic things we need to know before we start probability. Okay. So let's say this condition. Let's say there is a dice roll. Okay. So there is a um, dice roll. Let me zoom this a bit. Okay. So let's say there is a dice roll. So I say what is the probability that there will be an even number, right? So what this means, I'll not go into probability in detail today. So probability means basically the number of favorable cases by my total cases, right? So now what are the total cases for dice roll? It can be 1, 2, 3, 4, 5, 6. So it will be below, it will be 6, and favorable cases is what? Number of times it is even. So number of times it is even is 2, 4, 6. So 3. So my answer will be 1 by 2. So can you tell me what is the most important thing in this thing? The most important thing in this is this finding this number 3 and number 6. Okay. So this is the things we need to find in reality. So today we are going to talk about nothing but counting. How do we count? As simple as that, nothing else. So first, when we move to counting, we discuss about two principles. First, the multiplication principle and my addition principle. How do I decide what happens when? So let's say let's take an example here. So if let's say there are two towns here, let's say two towns here, three towns here, okay, and let's say one town here. Okay, so now I tell you what is the how many ways can we move from town A to town B. In how many ways can we move? So let's say when we start with A, we can go from here to here. Okay, so let me take a different arrow actually. So here to here, here to here, here to here. Okay, and from this we can either go here, here, here. So there are how many paths here? Can you tell me how many paths can we take? So there will be this path, and this path. Okay. So instead of A, if I did something like this, there was an initial point here, and let's say I bring this A here. So how many ways are there now? So from this, there are two paths. So there are two paths from here, and from this path also we can go in 6 ways, 3 ways. So this is my total case. So if you notice something, from A to B, whenever we are going, right? So from the inner points, so for one of these there are 3. From one of these are 3. So if you notice, if there were n values of this, and let's say if there are n values of this, so total how many ways are there? So there will be m into n ways. So what are we doing here? We are basically doing the multiplicative principle here. So why is it multiplicative? The main word for multiplicative is dependent. This path is dependent. Like if I choose this path, let's say, this is dependent on this one. It's not independent here. So it's dependent on this one. That's why we are doing the multiplicative principle here. If we go along this path, let's say, so we have to go back here. So the decision we take here affects the decision that we take here, if you understand. So this is how we are going to use multiplicative way of thinking here, nothing else. So this is how we deal with the multiplicative thing. Now when do we do the addition thing? So let's say it is not at all related here. So like if this is one case and this is another case, okay, the same thing, same case is done. So let's say this is P now and this is Q now. So what will be the case here? P into Q. So this, does anything from here depend on this? It doesn't. So what will be the total count here? M into N plus P into Q. So we're adding. So the main thing that here is, it has to be independent. Okay. So this is the main two. There are actually three properties: multiplicative principle, additive principle, and bijective principle. But I'm not going to go in bijective principle. This is enough. So when to multiply, when to addition, I think everybody has understood how to do it. Now the main next thing, let's do one sum. That would be better, I guess. So let's say I give you this sum. There are seven license plates. Excuse my spelling. Okay. So it is given first three are letters and last four are numbers. Simple. So tell me how many ways can we arrange it. So the first place. So here you can see first being a letter will affect, right? So let's say if A is there, for A there will be 26 cases. What after it will come? It can be AA, AB, AC, etc, etc. So in the first case we can choose it in 26 ways. In the second case we can also choose it as 26. Then number, so we can choose 10 into 10 into 10 into 10. Do you understand why we are multiplying? We are multiplying because the earlier thing depends on the earlier thing. So if it is let's say A here or it's B here, the values here will be a different combination or permutation of that one. Okay. Now this is basically the basic multiplicative and additive principles. Okay, so now we'll move on to something very important, that is called permutations and combinations. Okay. So let's say if I say how can you permute the three letters A, B, A, B or C. So you can write what? ABC, ACB, ABCA, BAC, CBA, CAB. I think these are the only permutations. So you notice something. Yeah. So basically we had three objects here ABC and we permuted them. Okay. So basically here you can see the order is mattering a lot. Okay. So since ABC and ACB are different things, but in reality if I told you to from a bag of 500 let's say words, let's say from a bag of like 26 letters, I'm telling you to pick 3, right? So in that case it does not matter which order you're picking up, right? So let's say all the 3 I picked up are ABC. So it does not require the fact that if it is ABC or ACB or CAB, that kind of condition is basically my combination, where my order does not matter. But here my order does matter. Permutation, order matters. Simple. This is the only difference between permutation and combination. Okay. So combination simply means that the order is not mattering. I am just picking anything. And permutation means order matters. Okay. So let's delve into permutation first. Okay. So basically let's say if I had the choices A, B, C and you're making three current stuff. Okay. Let's say 3 stuff. So like, so what will be, basically my box will be something like this. Wait a second. Yeah. Something like this. So I can fill any letters here and here and here. So in my first thing, what can I fill? I can fill A, B, C. So how many choices do I have? 3. Now if I have filled A, B or C, I cannot fill the same letter the next time. So how many choices will I have? 2. And the last one 1. So if you see, it is giving a very n factorial vibes. Okay. So basically when we have n objects, basically the permutation when you are putting in n places, it's n factorial. Now let's say if I didn't have here, I didn't have 3, I had, let's say, something like 5. So in the first case I could have filled it in 5 ways. In the second case I could have filled it in 4 ways. In third way I can fill it in 3 ways. So it's not giving a factorial vibe now. But now what is it? It's basically 5 factorial by 2 factorial. Can I say this? So the only missing terms here are 2 and 1. So what is 2? My last term, right? My last term. So what is my last term? The number of boxes. So we name the number of boxes here as R and the number of letters as N. So my final NPR, number NPR becomes nothing but N factorial by N minus R factorial. So this is the formula for permutation, as simple as that. Okay. Okay. So this is the basic formula. I showed you how it is derived. Okay. So basically, let's say if I give you the case, let's say, yeah. So how many different letter arrangements that can be formed using the word pepper? Okay. So your logic is simple. So basically, what is your logic? Basically, we have n 6 boxes, 6 letters. So what will be NPR in this case? So it will be nothing but 6p6 is equal to what? 6 factorial by 6 minus 6 factorial. So 6 minus 6 factorial is 0 factorial and the value of 0 factorial is 1. So it will just be 6 factorial. But there is a catch here. So let's say I have this sequence P P E P P R. Now how do I know? How do I know which P? Let's say why I'm saving shit. Wait. How do I know which P is which P? It can be this P as well, it can be this P as well. How do I know that? I don't, right? So there is some ambiguity. So in this case, what happens? There are I have considered a few extra cases for distinct P's, right? So what I will do is, how many extra cases did I count? I counted as many extra cases as the number of P's are there. The permutation of that is there. So if there is P1, P2, P3 is there, right? So how many ways can I mess this up? I can mess this up using permutation 3p 3 times. That is what? 3 factorial times. That is what? 6 times. So I have messed up 6 times. So in this case it will become 4 factorial times. That is 24 times I have messed up. So my final answer will be nothing but 6 factorial by 4 factorial. So in your exam, whenever you are getting something like even the word, let's say mathematic, right? Mathematics. So mathematics is how many letters? 11 letters. So total it will be 11 factorial. Now count the common words. So let's say A. So here it will be 2 let's say, so 1 2 factorial will come. And now again let's go T is also common 2 times and nothing else is common. Okay, so it will be 2 into 2 factorial. So this is how you solve permutation sums. Okay, simple logic, not that hard. Okay, So combinations also I have explained. Now combinations was what? I had considered extra cases, right? So how many extra cases will I consider? Same here, same logic, same logic. So how, as many as my containers are there, so this is the number of boxes are there, that many factorial cases I had considered. Okay, less. So my final output should be that many more. So my final NCR formula will become what? My permutation form. So sorry, I said it wrong. So basically you had considered it extra, right? So like A, B, B, C, these are the extra cases. So we will consider them to be 1. So how many did we take extra? That is the number of container factorial times more. So now my NCR will be actually divided by that. So that will be nothing but NPR by the number of extra terms we took, that is R factorial. So my final formula becomes what? N factorial by R factorial into N minus R factorial. So this is my formula for combinations. Okay. So just whenever you are doing an exams, just copy paste this and just do it, solve it. Okay. So that's it. This is I'm not giving sums for this. This is very simple sums. Now what happens is that we'll learn about something very important, that is called the binomial theorem. Binomial theorem. So binomial theorem states this. I will now share something and teach. Yeah. So binomial theorem is this theorem. So it is x plus y to the power n is equal to summation of k into 0 to the power n x nk xk y n minus k. Okay. The first proof is done by induction. Okay, so what is induction? Let me explain it here. So in induction, what you do, okay, these are some small bits which are not in syllabus, but you should know. So induction is that, let's say if I have a theorem, right? So how do I prove it? I put the value n equal to 1 and then put the value of n equal to 2 and show it's true. So if for both the cases, you have to show it's true. Next, what you will do, you will consider any case n is equal to k and n is equal to k plus 1. So what you have to do essentially is that we have to assume this is true. This is true, you assume that, okay? You assume that that is true and then you try to prove this is true. Then it will be true for all the values of n. So what happens is that if you prove it for 1 and you prove it for this, then it means it's true for 2, it's true for 3 and so on. So here also we'll do something like that. So for x n equal to 1, put the values in this equation and it's coming out to be true. Now let's consider the case n minus 1. We'll take the case n minus 1 and try to prove it for n, I guess. Okay. So they have done for n and n minus 1. So they are considering this, the case for n is true. Now they took the case for n plus 1. And I am not going in depth of the proof here, you can read the proof here, and then they proved this is true. So in that way, by induction it proved. You can also prove it by combinatorial proof of this. So basically what they're doing, this is, if you multiply all of them, you are getting this equation, simple logic. Okay. So there will be 2 to the power n terms because there are n terms and there are 2 terms. So 2 into 2 into 2 into 2 to the power n terms. Okay. So basically, let's say if we have any term, let's say y, let's say we have any term y x to the power m y to the power m. Okay. So how many ways can we choose m? So in reality, we can choose, how many ways can we choose x? So basically the reality in the question that becomes is that we have n terms and we need to choose m things from that. Okay, so that is simply nothing but NCM, right? In this, essentially this k value of this becomes nothing but n minus m, n being the total number of fillet. So see, that is how we get. So for each term we have to add, because it is not related. Do you think one term is related to another? No, by the additive principle we are adding. So simply we get this equation like that. So see, x to the power k. So how many ways can we choose k things from n terms? That is n c k. So this thing is also written in this fashion. So that is why that might be confusing. So basically whenever we write c, we can also write it like this. So n, if we write this is equivalent to your n c k. So this is basically what we have done, is nothing but binomial theorem. So how does binomial theorem help me? So let's say it can come to expand something or anything like that. Okay, so yeah, so this is binomial theorem. Yeah, so today's last topic is something called, we want to find the number of integer solutions in an equation. So for example, I have an equation x1 plus x2 plus, and wait, x1 plus x2 plus dot 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 plus xr is equal to n. This is my equation. Okay, so how do I solve this? Okay, these are all integers. Okay, positive integer, let's say. Okay, how do I solve this? So can I consider this to be a ball and stick problem? So if you have done maths earlier on, you should have learned this, something called ball and stick problem. So what is ball and stick problem? So basically we will have n balls like this. Okay, let's say I'll have some balls here, and so on. Okay, so this will be like, here it will be so on. So there will be many balls. Okay, so my first rule is that, okay, so first condition is it will be a positive integer valued function. Sorry, positive integer values. So this will be, let's say, positive integers. That means I can't have 0 as a value, right? So let's say I have to place, so how many balls are here? So I have n balls. Okay, now I have n balls, and now let me place some sticks like this. Okay, 6, yeah. So I'll place some sticks like this. So what do these sticks signify? So we have to count the number of balls on the left of the stick. Okay, every time. Simple logic. So here how many balls are there? 2. And here how many balls will be there? 3. And here how many balls will be there? 2. And so on, we'll keep on doing it. So this one is my x1. Simple logic. Do you understand this analogy? This is kind of the analogy we are making here. Okay, x2 and so on. This is my analogy I am making. Okay, on the left side. So can you tell me how many balls will be there? So there will be basically, how many sticks will be there? So we can put maximum r minus 1 sticks. Why r minus 1 sticks? Can you tell why r minus 1 sticks? Because see how many partitions we have. We have r partitions, right? So if we had one more stick here, then it would be r, right? So for each there will be something. But here we have r minus 1 sticks here. Simple, because we are taking one, we can't take this case, right? Why can't we take this case? If we take this case, there will be 0 here, right? There will be 0, but we can't allow that. So no, we have r minus 1 sticks. So now r minus 1 sticks. So how many places can we place it? We can place it anywhere. Like we can place it here, 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 till this one. Okay, but we can't place it here. The stick can't be placed here. So there are how many locations? There are n balls. So there are n minus 1 locations. So what will be my number of possible combinations here? N minus 1 C R minus 1. So can we tell n minus 1 C R minus 1 is the solution for positive integers in this function? Can we tell this? So this is the logic of how we approach these kinds of problems. So this was for positive integers. So for positive integers, plus 0, means it's whole numbers, the formula changes to n plus 1 plus r minus 1 cr plus. This one is your homework. How did this come? This is your homework, home task, or whatever you say. How did this come? Same logic, nothing different. So positive plus integers, we have this equation. Okay, so for example, nowadays let's say if anybody तुम जाते हो रास्ते में और तुमको कोई पकड़ के बोलता है, so I have 20,000 rupees and I have 4 friends. What are my possible ways of sending money to these 4 friends? But everybody has to get money. So what is this? This is positive integer case. So what is n minus 1? What is n minus 1? 19,000 is my n minus 1, right? So 19,000 n minus 1. Sorry, 19,999 is my n minus 1. C. What is my r minus 1? 4 minus 1, that is 3. This is my answer. You can solve these problems in one line. So that's how easy it becomes. Okay. So this is how we are going to solve counting. So this was the introductory class. We will move into probability from the next class. So bye bye, and please solve the extra sums I'm going to give in the below part in the description. Check out all the works, and you will also find the text from which the thing was taught in the description.